Welcome to Compute Service Comparison based on AWS Solutions Architect Topics by Abilid. We offer microservice introductions, exam question explanations, and practicing of real exams. With container services, you provide flexible app packages on compute servers. By comparing with the EC2 virtual machine, you can see the container's strengths. Containers are built to form medium-sized unified app packages with its OS to be used on any machine in the cloud or on-premises. Because of this, you can quickly migrate containers for microservice-based apps and event-driven IoT device apps. In contrast, only a single, large EC2 virtual machine finds place on a physical server to customize and control app-heavy enterprise websites. ECS and EKS service are highly scalable, have a low overhead with simple and flexible app packages for any machine. Now let's have a look at the container services and their collaboration. Find your container microservice in a pipeline. First, create a container image in repositories such as GitHub and transfer the resulting Docker package to the ECR storage and registry. There you map it to one of the main container management services, ECS or EKS. You configure the ECS task or EKS pod as the smallest unit for further coordination on the final server. Finally, these units can be hosted on the server by the EC2 or preferably by serverless Fargate launch types. This completes the pipeline by launching the final app container based on the ready-to-use image. Can you also build common cloud architectures with containers? Its services can activate an autoscaling or balancing function, or be integrated into services that perform the same functions as part of a larger architecture. This applies to both the main container service ECS and EKS, which you first must choose. ECS is AWS-based with less features, simple to use, less costs. In contrast, EKS with its various features to perfectly integrate with Kubernetes. For either choice, the processing is the same. To start with the architecture, you configure clusters, containers and tacks or pods via the console for the managing control plane. The tasks in this example run by Fargate launch type. Secondly, the app load balancer service distributes the traffic evenly across the tasks for their app. Next, the autoscaling service increases or decreases the number of tasks according to a policy and in collaboration with the control plane. Finally, Fargate runs accordingly the task with its app blueprint and the needed containers. As you can see, the flexible container services are well integrated, which also allow a targeted routing of individual tasks with the load balancer. If you want to prepare and safely pass the AWS Solutions Architect Associate exam, we recommend to also practice our real exams on Udemy. We wish you further insights with Abilid videos.